Hello, this video is going over the solutions to the how much can you carry worksheet. It uses z-scores and the normal curve to calculate areas and probabilities and also come up with cutoff values of stuff. Um, let's start with number one. If Tony can type 40 words per minute without making a mistake and Monique can write out 34 words per minute without making a mistake, then who is better at their skill? Notice that this one is typing, where for Monique, she's actually writing them out by hand. So you have two different things. This is an apples orange situation, and you want to know who's better. So this is who's better relative to what they're doing, right? I mean, there's no way to directly compare apples and oranges, but using z-scores, you can compare how good they are compared to their peers. Like here you can see we have typing average and standard deviation and the writing average and standard deviation. So relative to these benchmarks or these averages and stuff for their peers, are they better or worse? Okay, so what you always do is just find a z-score. That's all you need to do. So z for Tony maybe, and you take Tony's value minus the mean divided by the standard deviation, and I will get 0.792. I'll round it up a little. Then the z-score for Monique, take her value, 34 minus 22.8 over the standard deviation of 5.1, and you'll get 2.19 or 2.2. So I can see that Monique writes faster relative to her peers than Tony can type relative to his peers. So Monique is better. So Monique is better. Now, just because the z-score is larger doesn't always mean it's better. There are certain situations, like let's say you're racing, like swimming or running, and where a smaller value is actually better. Like when you're running, you want to have a low time, right? The faster you are, the smaller your time. So just be wary that sometimes the bigger isn't always the better. Yeah. All right, part B, same idea. We have Jet is a sled pulling Malamute, and he can pull a 290-pound sled for 20 feet. Brute is a competition pit bull and can pull a 130-pound sled for 20 feet. The two dogs are in different categories. You get the heavier sled dogs, that's the Malamute, and smaller dogs like pit bulls. Which one is a better puller relative to the peers given in their parameters? Okay, so the Malamute is a big dog in the big dog category. So they can pull 290 pounds. Subtract the 325. Sorry, Z for who's this? Jet. Divide by 19, and you will get a negative 1.84. The z-score for Brute is 130 minus 150 over 26. So minus the mean divided by standard deviation, and you'll get negative 0.77. So when I look at these, they're both negative. So both dogs are actually worse than their average, right? They're lower than average at pulling. So they're not great at pulling. But we just want to know which one is best, I think. Which one's a better puller, right? So since they're both in the negative, I want the one that's least negative. So actually the Brute, this one, is better. He's less worse, right? If that makes any sense. Number two, a sample of 50 old tankers was taken. The weight in metric tons they are carrying was measured and following statistics obtained. What weight or less do 95% of the ships in the sample carry? So this is percentile rank question. Percentile rank always means the cutoff value and less and less. So if you're taking an SAT test or something like that, some standardized test, when they give you your rank, like, oh, you're in the 80th percentile, when they do those, that's telling you your score represents right where the cutoff is for 80% of the people who took the test. So 20% did better than you, 80% did the same or worse as you. Okay. All right, but so they give me the mean standard deviation. We want the percentile for 95%. So this, we need to first figure out like how many standard deviations we're going to go up or down. So 95%, the z value for 95%, a z score, is 1.645. This is a number we want you to memorize. For the 95% cutoff, it takes 1.645 standard deviations. Now, you can look that up on the calculator as well. So if you need to figure that out, you can use an inverse norm on the calculator and put in like negative infinity up to 0.95, and it'll tell you what the z-score is for that. Oh, sorry, it's giving you, you put in you put in the area, and then the mean and standard deviation is what you put in that. And then it'll spit out the 1.645 for you. So you should try that if you're not familiar with how to use inverse norm. There are videos for this that you can find on our doc, and you should practice it out right now. Just make sure you can do it. Okay, so once I know how far that is from the mean, then that's all I have to really do is just say, okay, from my mean of 256,000 tons, I want to go up 1.645 standard deviations, and each standard deviation is 47,000. So this is telling you where the cutoff is for 95% of the tons of weight in the oil tankers, right? So this will give you 308 tons. So that's 333,000 tons. Okay. On the back, number 3, in order to maximize efficiency, a minerals company informs their dump trucks to carry 3.4 tons of earth away from the site on each trip. Too much and they are dangerous, too little and it's not efficient. So if the trucks have a standard deviation of 0.17 tons, how much do the middle 95% of the trucks carry? Now this is a confidence interval for an individual truck. Don't get it confused with the confidence interval for the mean, which we're going to be doing later, like towards the end of the year. We're going to do confidence intervals for the mean of a population. Right now, we're doing confidence intervals for an individually randomly selected thing, in this case, a truck. Okay, so we want the middle 95%. Well, if it's 95%, that means that you need to go up and down about 2 standard deviations. But another number we want you to memorize is a z-score of 1.96. So 1.96 is a z-score we want you to memorize. And this goes along with 95% confidence. Now let's take a look at this on the side. It doesn't mean that, like before when we were doing percentile rank, it was 95% all the way up to a point. So we shaded like all the way down. But in this case, there's this top tail and this bottom tail that are not part of the 95%. It's only 95% in the middle. So this middle is 95%. So the cutoff, this cutoff, when you're using inverse norm, like if I was going to try to find this value using inverse norm, I would have to include the little lower 2.5%, so that if I were to find this, I would go inverse norm of point, I got to do 97.5%. 975. And that would give me this Z of 1.96. Okay, so in any case, this cutoff for 95%, it's not really 2, it's 1.96, very, very close to 2, but we want to have a little more accuracy. Okay, so I need my confidence interval. So from the center, 3.4 tons is what they want the center to be. I'm going to go up and down 1.96 standard deviations, which is 0.17. So from the center, you go up and down a certain amount, and how many standard deviations you're going to go up and down. And that will give you an interval. If I go down, I'll get 3.07. If I go up, I get 3.73 tons. Right? So this is a 95% confidence interval. What does that mean? If I randomly selected a truck, any dump truck from at any time in the day, on any day of the week, if I just randomly select a truck and I weighed it, 95% of the time, it will weigh somewhere between 3.1 and 3.7 tons, right? About 5% of the times 2.5% of the time it'll weigh less than 3.1, and 2.5% of the time it'll weigh more than 3.7. So, together that makes 5% where it's not in this interval. But it's randomly selecting a truck. How much do the middle 80% of the trucks carry? Well, if it's the middle 80%, that means there's 10% on each tail. When I put it in the calculator to do my inverse norm, the calculator takes into account percentile rank. It likes to do percentile rank. So it's going to take all the area over. So it's going to take the middle 80, but it's also going to include that 10%. So I'd have to do inverse norm for 90%. And that will give me a z-score, or a z value, of 1.28. 1.28. So not a number that you're going to have to memorize, but it does come up quite a bit because it's the 80% in the middle. Most of the time, 95% comes up a lot, and kind of some other ones do too. But this 1.96 is important, and the 1.645 is more important. Okay, so now I can use that from the middle, 3.4. I'm going to go up and down. In this case, I'm going to go 1.28 standard deviations. So everything's the same as what I did before, but the z-score has changed because I want a different middle. I don't want 95%, I want 80%. And you get an interval again, 3.18 and 3.62 tons. Sorry, I'm going fast and trying to stay out of the camera's way, so my writing's a little messy. Sorry. All right, now we're doing percentile rank. So what percent of the trucks carry less than 3.2 tons? If they say less than a number, that's percentile rank. So let me do the shortcut on this. Like the shortcut, if this was a multiple choice question, I'd just go right into norm CDF. And I would say from negative infinity up to 3.2 with a mean of 3.4 and a standard deviation of 0.17. And I would just put all my actual numbers in the calculator. You don't even have to use 0 and 1 or anything. And that would give you your actual answer for the problem. So on a multiple choice, it goes really quick if you just say norm CDF. Norm CDF is set up for percentile rank. That's what it does. It gives you the area from a cutoff and below. You could do that. It's a long way. But if it's a free response question, you got to write it out. And what we want to see is the z-score to begin with. So 3.2 minus 3.4 divided by 0.17 standard deviations. And when you do that, you're going to get a negative 1.176 standard deviations. The next thing we want to see is the probability of that z-score, and in this case being less than negative 1.176. And I'll just put it over here, equals. So this is notation we want to see, and we want to see the z-score calculation. This you do on your calculator. Now, if I wanted, I could do the same thing with norm CDF, but instead of using 3.2 and 3.4, I can put in the negative 1.176 and use 0 and 1 now. whoops, sorry, there it is. I'm putting 0 and 1 as my median standard deviation because I'm putting z-scores into the norm CDF. Either way, when you put it in, you will get 0.961. Oh no, I lied. That's the wrong problem. Sorry, that's not correct. It should be 0.11979. I was looking at the wrong number. All right, so next problem, very, very similar. So I'll go faster. Greater than 3.7. 3.7 minus 3.4 to get the difference. Divide by standard deviation to normalize it. That will give me 1.765. The probability of my z-score being greater than 1.765 is, and you put that in the norm CDF, and you get your 0.961. Next problem, how much do the lowest 20% of the trucks carry? So now we're looking for the number instead of the percent. So we're doing it backwards now. They're giving us the percent, and we have to find the cutoff value. Before we had the cutoff value, and we were trying to find the percent. So we're doing it backwards. So 20%, what do I need? I need to know what z-score matches 20%. So when you do it backwards, you do the inverse norm. This is the lowest 20%, so I'm just going to put in 0.2. That's the area I'm looking for. And just do 0, 1. That's okay. And when you do that, you will get a z-score of negative 0.8416. Okay, so obviously 20% is below the mean, right? Because it's on the lower part. All right, so that is our z-score, which I can go back to this equation now and fill that in. So negative 0.8416 equals what I'm looking for, minus 3.4, 0.17, and then you just solve that for your x, right? So 3.25 is the value. This is tons, right? Does that make sense? 3.25, the average was 3.4, so this is below the average by a little bit, right? So that all kind of makes sense. So just doing the same calculations but backwards. What's the z-score of a truck that carries 3.15 tons? We just want the z-score. So that's pretty simple. 3.15 minus the mean, divide by standard deviation to normalize it, and you'll get a negative 1.47. Last problem. What percent of the trucks carry between two values? Okay, this is kind of like giving us a confidence interval, and we have to come up with the percentage that confidence interval matches. Now, 3.4 is the center, so sometimes I like to check to see if it's all symmetric. So 3.4 to 3.5 is 0.1, but if you go down to 0.25, that's not the same, right? So it's not 0.1. So this isn't really a confidence interval. It's just a probability. And the easiest way to do these is to do norm CDF. Before I was talking about how norm CDF likes to do percentile rank and goes all the way to the bottom, which is true, but a lot of times you'll notice that I'm putting in norm CDF, I'm putting in the negative, let me roll this back up. I'm putting in the negative infinity to tell it to go all the way to the left, right? Which you don't always have to do, which is in this case, we're not going to. I'm going to just tell it what to do. So the lower bound, 3.25, upper bound, 3.5. Put in your mean and your standard deviation, 0.17, and you'll get your answer. Now, this is the shortcut way that you can do it on if it's a multiple choice question, you get 0.533 when you do that, so 53%. But if it's a free response question, you have to find these z-scores. You actually have to find out what's the z-score, 3.25, and find out what that is. What's the z-score of 3.5? And find out what that is. And then you can go in and do the norm CDF and come up with your value after that. But you have to show that z-score calculation and then come up with your probability between them. They even like you to write out the probability of between, like whatever these z's are, right? I don't have them written down. So whatever they are. So you put the first one, and then you'd say my x value being greater than one and less than the other, right? And you'd write that out before you got your answer. Okay, that's it for that worksheet on how much can you carry.